Just like we undo addition with subtraction, undo division with multiplication, we can solve quadratic equations with that x squared term using square roots. So, for example, if you've got some number greater than 0 or variable greater than 0, then the equation x squared equals s has two real number solutions. So when we take the square root of a number, it's a positive and negative value. Because if you think about it, if you guys took the square root of 9, the square root of 9 could be 3 times 3, or the square root of 9 could be negative 3 times negative 3. So when we take the square root of something, it's always going to be a positive and negative value. So we usually just write it as plus minus, like positive and negative. We write it as two solutions and one. But this really counts as two solutions, a positive and a negative. But that's really all you do to solve square root equations is you undo the square exponent with a square root. So when we look at trying to solve some examples, the only thing we have to keep in mind is that you have to get the expression that's being squared by itself first before you can undo it and take the square root. So when we're looking at example 5 on the next page, we want to get this by itself. So that just means we have to move the 3 and the 5. So let's just regular inverse operation. So if we have plus 5, we're going to minus it over. Get 3x squared equals 36. And then it's 3 times x squared, so we're going to divide by 3. Get x squared equals 12. So at this point, you have, sometimes it's a variable, sometimes it's an expression, but you have the thing squared to be the only thing on the left side. So just like you undo addition with subtraction, you undo a square power with a square root. That is what undoes that power and leaves you with just x, which is what we're trying to get. So x is going to equal positive and negative whatever the square root of 12 is. So we're not going to leave it as that. If we can simplify, we want to do that. So we're going to factor 12. So 2 and 6, 3 and 4. So we've got that perfect square of 2 in there. 3 left. So x equals positive and negative 2 root 3. So like I said, you could write it, I guess, as two separate answers, but we will generally just write it as the one. Like together, positive and negative 2 root 3. So get whatever is squared by itself first. So for number 6, same thing. Get the x squared, so we need to move the 15 and the 2. So minus 15, we will add the 15 over. 2x squared equals 80. We still have the 2 with that x squared, so it's times. We need to divide both sides by 2. Get x squared equals 40. Okay, so at this point you have the x squared term by itself, so we will take the square root of both sides. That undoes the squared power. Roots and powers undo each other. X will equal positive and negative whatever the square root of 40 is simplified. So 5 and 8, 2 and 20, 4 and 10. Factor it out. So we have a pair, and these two guys are left. So that pair is your square. So 2, 5 times 2, 10. So x equals positive and negative 2 square root 10. So it's just a variable squared. Get that by itself. Take the square root to undo the squared power. So in number 7, we actually have a whole expression that's squared. So the only thing we have to move or undo is this 1/3. So 1/3 times x minus 4 squared. We have to recall how to undo fractions. So whatever's in that denominator, because that's what we're really dividing by, like multiplying by a third is like dividing by 3. So if we're multiplying by 1/3, we're just going to undo that by multiplying both sides by 3. That will undo this, leave you with just x minus 4 squared. 11 times 3 is 33. Okay, so this is just an instance where we have an expression squared instead of a variable squared. So at this point, since this whole thing is to the squared power, we're ready to undo the squared power. So we will take the square root of both sides. That undoes your exponent. Leaves you with just x minus 4 equals positive and negative. Whatever the square root of 33 is simplified. So like you guys could try to factor it, but you'd really only get 3 and 11, which would end up just multiplying back together. So there's no perfect squares in there, so that one we can leave as is. It's already in simplest form. Okay, so we still don't have x by itself yet though. So the last thing to do is add the 4 over. So now we do have x by itself, but we can't combine these together. Like 4 is a regular number, 33 is an irradical. So we don't want to make this like 29 or 37. We just simply have that positive 4 plus or minus the square root of 33. You guys could also write it as positive or negative square root 33 plus 4. We just generally write the root as the second part. Like if you have a regular number, that would be second. So that's why we would put the 4 in the front instead of the end. But it doesn't matter. Just don't combine them. You just had that positive and negative square root 33 plus the 4. So that is it. No decimals, just an answer in simplest form. So the big thing with this is to remember just getting the part that's squared by itself first. And then when you do take the square root, just automatically put that positive and negative there because you're always going to have 2 answers. So it might seem little, but that positive and negative plus minus in the front of your square root is important because you should have 2 answers, not just the one. But other than that, like you'll have different steps each equation, but you just use inverse operations to get the squared expression or variable by itself, and then take the square root, go from there.